In this chapter, we will focus on using the entity relationship or ER model for data modeling purposes. An ER model or diagram allows us to visually represent the relationships between entities in our created database. Throughout this PowerPoint and in Chapter 3 of the course textbook, you will see examples of ER models and diagrams based on relationships of entities to account for all possible entities within a database. The topics to be covered this week are an overview of the database design process, an example database application company, and the entity relationship model concepts included, how to notate them, how to diagram them, as well as other alternative diagram options, and the relationships of higher degrees, known as N-ARY. For the purposes of this course, your projects will focus on database design using software provided online by Rowan University. This diagram gives an example of the database design process. It is not a specific ER entity relationship diagram. There are other forms of conceptual design, but the most common are entity relationship, ER, and enhanced entity relationship, EER. The first two referenced here. Think back to the university example in Chapter 1. Consider what entities are involved. Here we have listed departments featuring name, number, and employee, manager, and projects with a project name, unique number, and single location. In theory, both departments and projects could have more sub-entities, hence the simplified requirements referenced. Now we are getting into potential HR requirements. Again, each entity could have more sub-entities than are described here. An entity is the highest rank within the database, such as employee, department, and project within this company example. Attributes, or sub-entities, as I previously referred to them, are the associated parameters. Examples of the attributes for the employee entity are listed here. You could also include phone number, emergency contact, and other possible attributes to this entity. An entity with a simple attribute means it is set up with one value possibility. Social Security number is an integer and sex is a string. Composite attributes can feature a combination of data types. For example, address will include strings and integers. Some multi-valued attributes will feature a drop-down menu to choose from with the possibility of multiple answers available to you. Attributes can have other attributes associated with them. Here is a breakdown of an address attribute. You will notice street address is broken into additional attributes of number, street, apartment number. A key attribute may be composite. An entity type may have more than one key attribute, which is also referenced here. Examples of the composite nature of key attributes, how are multiple key attributes possible, and how keys are labeled in an ER entity relationship diagram are provided and described here. Entity set can change based on the needs of your database. As they change over time, you may change your entity set. Value sets can be changed based on your needs as well. For example, prior to 2000, date of birth was usually written out month, month, day, day, year, year, with those being generally a year of 1999, 1919 as an example. Now, with individuals born both in the 20th century and 21st century, we had to expand to year, 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 year to accommodate for this. Both attributes and value sets are set for your database and can be changed as needed based on new information. Here you're provided information on how an entity relationship diagram is created. Make sure to keep a note of these descriptions for creating an entity relationship diagram later. This slide delves further into all notations for an ER entity relationship diagram. You will see these throughout this chapter, described within this PowerPoint, as well as in the images when we actually build our ER diagrams. The example A provides part of an entity relationship diagram. The example B provides possibilities based on our entity set, our registration number and state, our vehicle ID, our make, our model, our year, and our color. The registration number is more than likely your license plate number. There could be more entities within the company database, but these are the examples provided by your textbook. This is an entity relationship diagram for each of the 4 entities, but not an overall entity relationship diagram for the company database. Slide 22 did not touch on relationships, only on entities and attributes. Relationships connect entities. Relationship types explain how these entities relate. If an employee only works for one department, this diagram works for us. However, consider if someone worked for multiple departments. We will touch on these notations later in this chapter. You'll notice here, employee E3 works on multiple projects, so the diagram from slide 25 is modified from projects to departments. If relationship type changes, the database reflects the current relationship type and ignores all previous states of the relationship type. As described on slide 19, relationship types are represented with a diamond-shaped box. If we were to find these in a sentence, they would read as: employee works for department, employee manages department, department controls project, employee works on project, employee supervision employee, employee dependence of dependent. This slide provides an entity relationship diagram, including all relationship types within it. Think of how the English language works when associating relationships. For example, an employee can work on a project, but can't work on a department. They can work for a department or in a department. In a lot of cases, relationships will consist of many-to-many relationships. Relationships can also be optional. A many-to-one relationship exists for the employee and department relationship because that is how this company database was defined by the course authors. The textbook authors indicated it this way. A many-to-many relationship exists for the employee and project relationship. In this instance, you are choosing 2 different employees from the employee entity to represent the relationship. One is in the supervisor role, the other is in the supervisee role. Detailing everything you can in the entity relationship diagram allows for the best setup of the database. Here, ask yourself, who supervises who? Can you determine it from this picture, diagram? Added within this ER diagram is the supervisor and supervisee and how they relate. A weak entity has attributes which could all be considered equally important. None of them may be a key. Relationship type may have multiple attributes, not just one. For example, works on might also include a location to and not just hours per week. The ER diagram provided here adds the hours attribute to works on here. You will see hours in between works on project in a oval. The ER diagram should notate how relationships work. The example, 1-to-1, 1N, N-to-1, or M-to-N, abbreviated. You can set constraints for your relationships as well. Here, one employee can only work for one department. In real life, this constraint is very unlikely. This diagram shows how each relationship works. You'll notice relationships can be different from each entity from one side to the other. This diagram has added constraint notations for our entities. You'll notice them. 0N for supervisor, 01 for supervisee, 11 for employee, 01 for manager, etc. Building an entity relationship diagram helps to build a complete and thorough database. All aspects need to be considered. Here is a reminder of how to diagram and what to use for notations in entity relationship diagrams. UML diagrams are less commonly used, but similar to ER diagrams. An example of a UML diagram is provided here. Some might be easier to read for some and harder for others. Some people prefer to use the UML diagram. Most prefer to use the entity relationship diagram. The UML notations for diagramming are shown here. When n goes beyond 3 and can represent any number above 3, it is referred to as n-ary, higher degree. Reference the n-ary relationships that are detailed within this chapter in the course textbook. Examples of a ternary relationship are provided here. You'll notice that part connects to 3 areas listed here. A, B, C. Part is the entity connected outward. Again, reference your text in order to view examples or the figures within this PowerPoint as provided. Offers connects to course, semester, and instructor. 3 connections, but visibly different than our prior example. Offers would be considered a ternary relationship. Constraints are important to fully understand relationships. University can be a very involved database, but this version is simplified. There could be more entities and attributes associated with this database example. A full ER entity relationship diagram is shown for the university example here. Hopefully, you're now aware of the following topics that were covered during this week's discussion. All aspects of database have their positives and negatives. Some of them are listed here. Here are all tools which could help in creating database models. It is best to first learn how to diagram by hand. This allows you to further understand how to set up a diagram and how to set up a database with the most information inside possible to avoid any issues you may have, especially if you're creating the database for someone else. As we will jump around with our chapters in this course, we will cover extended entity relationship or EER models later in this course. And that concludes our second week of databases.